This section is covering the analysis of bending of a beam, the shear force and bending moment acting on a beam is the first agenda. The illustration is a typical image of bending of a beam. In general, a beam is a long and thin rod-like structure. When a load is applied to the structure toward a direction vertical to the longitudinal direction as this illustration, the beam bends toward the direction of the load. The method of beam bending determines the amount of the deformation. First of all, we are considering how external loads and moments cause the shear force and bending moment, and then how they are distributed along the beam in the longitudinal direction. Now, a load is acting at the tip of this beam. You may imagine that a weight is attached at the tip of the beam. This means that a bending moment is generated at the root of the beam. Its value is determined by the product of the length of the beam and the load. This beam has a bending moment acting not just at the root, but also at each part of the beam. The value is determined by the product of the load and the length of the arm. In addition, shear force or shear stress act on this beam due to this external load. I have already introduced that a beam is a long and thin rod-like structure. This is an illustration of a section of the thin and long structure. It has x-axis along the longitudinal direction of the beam. It has z-axis toward the direction vertical to the x-axis, usually downward. Some textbooks may use y instead of z, but z, as in this case, may be more commonly used in the analysis of beams and plates. In this section, we are considering a beam that deflects toward the positive direction along the z-axis. First, we focus on how to deal with the shear force and bending moment acting on the beam. The shear force is the force that acts on the cross-section of the beam vertical to the x-axis.